We're going to do two problems real quick for section 6.3, and that will be the end of our chapter. So in this first one, we have a pilot. He wants to fly straight north a distance of 125 kilometers. The wind is blowing out of the west at 35 kilometers an hour, and the plane can travel at 175 kilometers an hour. Now I know if we're going to start here and go here, and the wind is going to be blowing this way, he's going to have to fly the plane somewhere like that. And we're going to need to find his velocity right here before we can figure out how long it's going to take him to go this distance. So how long will the trip take? One of the equations we were given talks about how to find our relative velocity. So for this, I'm going to use the relative velocity of the plane to the air plus the relative velocity of the air to the ground, so AG, is going to be equal to the velocity of the plane to the ground. Now, the velocity of the plane to the air would be 175 kilometers an hour. So I'm writing down 175 kilometers an hour. And then I have the air to the ground is 35 kilometers an hour. But what I don't have is this velocity of the plane to the ground. So what I can do is I can use the Pythagorean theorem here because this is a right triangle. This will be my hypotenuse. So I'll have 175 squared is going to be equal to, we'll call this guy x because I don't know him, plus 35 squared. So I can take 175 squared minus 35 squared is equal to x squared. So I can take the square root, and I'll find out that x is equal to 171 point, and I guess we'll just round that to 5. And that is still in kilometers per hour. I also know that v is equal to d over t from another equation earlier this year. In the distance I want to travel would be 125. My velocity is 171.5, and then I have t. If I rearrange my variables, I could take 125 divided by 171.5 to find t, and if I do that, I find out my t is 0.73 hours, and if I divide that by 60, if I multiply that by 60, because there are 60 minutes in an hour, I get about 44 minutes. Okay, that one wasn't too bad. Here's my second one. In my second one, I have a grizzly bear who wants to cross a river. So, here's my grizzly bear. Here's my grizzly bear's ideal location, directly across the river. The river is flowing south. I'll make that a different color. It's flowing south at 3 meters per second. And the grizzly bear can swim at a sustained 2.5 meters per second. And it asks, at what angle should it swim if it wants to reach the river directly across? So it asks for what is that angle. Now, for this equation, we actually have to use something that's been on your equation sheet forever, but we have not really had to directly use. Sorry, that's SOHCAHTOA. TOA. And that tells us, the so part tells us that the sine of theta, in this case with this being our theta, is going to be equal to the opposite side over the, I mixed those up, sorry. You guys probably realized that a while before me. And you can see that I just messed those up from the numbers they gave me in the equation. So opposite is 2.5, and my hypotenuse is 3. So if I do the inverse sine of 2.5 over 3, I will find out that my angle the bear needs to cross at is about 56 degrees north of east. So I always want to put a direction. So 56 degrees north of this line that's straight east. Sorry for messing up those numbers. And this is going to be a real short, quick one because we have 1:30 out. So enjoy. Thank you, guys.